Hi, and welcome to our final lesson of Unit 5. This is 5.5, and it's the lesson on slope. And slope is the rate of change between any 2 points on a line. It is measurement of the steepness of a line. Okay, well, what does that really mean? It just means that it is a way to measure how steep a line is. So imagine if you were looking at a hill and it went straight up, you would think it would be really, really steep. And if you looked at a hill and it was kind of gradual, you'd think, well, it really isn't that steep. That's really what you're talking about is slope. So we're going to talk about it when it means in lines. And slope is used for a lot of different things when you're working with lines. And how to figure it out is sometimes a lot of the times we talk about is the change in y divided by the change in x. Sometimes you'll also hear of it as the rise over the run. So this would be the rise, or the change in y, over the run, which is how long you run along the x-axis. So for this line here, you would pick 2 points, one right there and another right here. And so then you would find the point it kind of made the staircase, so that you have a straight line going the x-axis and you have a straight line going the y-axis. So you would start with the change in y. So from this point it would be 1, 2, 3. And like steps, you wouldn't count where you were standing, you would count each cross mark. So 1, 2, 3 till you get to the point. So the top number would be 3 and the bottom number would be 1, 2. So it is the change in y divided by the change in x, or the rise over the run. All right, well, let's look at this as an example, as a real example. And I'm going to put rise divided by the run. So in this case, we're going to pick the points 0, 0, and 3, 4. So the change in y, so we draw a line that goes out to here and a line that goes up here. So this is the change in y, is the steps that it takes to go from the x-axis, 1, 2, 3, 4. So that would be 4. And the run would be, from that point, 1, 2, 3. So your slope would be measured as 3/4. Okay, well, let's look at this one. And it doesn't really matter where it starts, even though this is in the negative coordinate, doesn't really matter. We're talking about the rise over the run. And in this case, the rise is don't count for where you start. 1, 2, 3. So it is equal to 3. And the run, which is starting from here, 1, 2, 3, 4, 5, 6. So it would be 3/6, which, and we always simplify it, would be 1/2. So I always want to put slope in its simplest form. Okay, here we have finding the slope of a line and on your own. So pause me for a second and see if you can figure out what they are. Hi, welcome back. So in example 1, we're going to, and I'm going to use different, so we're talking about the rise over the run. So we draw a line, draw this blue line here. That is the run. I'm going to change it to red. And then this is the rise. Remember that it is the rise divided by the run. So in this case, since I'm in blue, I'm going to do the run first. Start from 0, 0, 1, 2, 3, 4, 5. And the rise is 1, 2. So it would be 2/5. Now, I don't know if you've noticed this yet, but this only works to count the little slash marks, if you happen, your x and y axes are marked in 2s. So this actually isn't going to work over here, where our x-axis is marked in 1s, but the y-axis is counting by 2, 4, 6 is counting by 2s. So again, we have the rise over the run. We're going to draw, so the line kind of looks like this and like this. So our slope is the rise, and we're starting at 5 and we're going to 8. So if you were to take steps, think about this, you starting at 5, going to 8, so 5, 6, 7, 8. You'd have 3. Or you could just subtract 8 from 5. You'll learn more about that next year. So it would be 3. And then the run is actually, that is counted in 1, so it's is equal to 3 over 1. And we would always write that as 3. So that's what that was. Okay, moving on to page 2. So example 2 is, this is a table that shows your earnings for babysitting. And here's a graph. And it says to graph the data, but I borrowed this one out of the book, so I didn't have to graph it. But 0, 0 would be here. 2, 10 would be here, okay, etc. So these plots are all plotted. Again, we're not going to be able to count because this is counted in tens, although the hours are counted in ones. So let's talk about the rise over the run. So we want to find the slope. So we're going to pick these 2 points, 420 and 840. So the rise is going from 20 to 40, or 40 minus 20, which would be 20 points. And the run, again, these are counted in ones, so we can count 1, 2, 3, 4. 20 over 4. Okay, so what does this really mean? If we look at the graph, the x-axis is hours. So it's actually, it should start to look kind of familiar to you guys at this point. And the y-axis is in dollars. So we're really kind of talking about $20 divided by 4 hours. Huh. If I simplify that, I will get $5 over 1 hour. And that should look like something very special we learned in section 5.1, which is a unit rate. So the slope can give us the unit rate. So it means that somebody in her babysitting job is earning $5 per hour. Okay, on your own. So on your own says, in example 2, use 2 other points to find the slope. Does the slope change? And the graph shows the amount you and your friend earn babysitting. Compare the steepness of lines, what does this mean in the context of the problem, and find and interpret the slope of the blue line. So pause me and then come back. Well, welcome back. So in example 2, it says to use 2 other points to find the slope. Does the slope change? It's an interesting question. Do you think it changes? Let's find out. And we're going to use 0, 0 to 10, 2, because that's kind of a nice one to look at. So from 0, our rise goes from 0 to 10. Oh, that's 10, so that's our rise, or our change in y, over our run, which is our change in x, and that's 1, 2. So that is also equal to $5 per hour. So no, it really doesn't matter which 2 points you choose. It's kind of nice to choose it so that your x is actually 1, because then you don't really have to simplify too much, if you can do it. But it does not matter, and that's because this is a straight line. And that's usually what we're talking about when we're talking about slope, at least now. Calculus is actually the calculation of the slope of a curved line. So that'll be your friend later. So the graph shows the amount you and your friend earn babysitting. So the blue is your friend, and green is just a repeat of what was up here in example 2. So compare the steepness of line. What does this mean in the context of the problem? Well, do you think your friend makes more or less than you do? Well, let's find out from the slope. I kind of think she does, because her line goes up higher than mine does, and it's a bit steeper. So I think she does. So let's find out if that's true. We already know that I make $5 per hour. Let's find out how much she makes. So we'll find out the slope of her line. So the change in y, so we're talking about the rise over the run. So the rise goes from 28 to 56. And remember I said that you can actually just subtract those 2 numbers. And then the run is this way. So it goes from 4 to 8, so that's actually 4. So if I figure this out, it turns out, I've already done the math, so I'm going to grab it off of there. That's 28 divided by 4. It's 28 divided by 4, which gives me $7 per hour. So yeah, Caroline is steeper and she does make more than I do. Thanks for watching.